And joining us here in the Launch Control Center in fire room number 4 is Tony Bartolone. He's the lead external tank and solid rocket booster project engineer. Tony, thank you for taking a couple minutes to talk to us, and specifically about the GUP, and actually what that is what led us to scrub back in early November, but it's not what's keeping us on the ground at the moment.
Good morning, Allard, and that's correct. Back on November 5th, we did have an off-scale high leak of hydrogen coming from the ground umbilical carrier plate. That did violate our launch commit criteria and forced us into a scrub. We've had instances of like that leak in the recent past. We had some ideas about what may be contributing to that, and that kicked off an investigation that followed thereafter.
So let's see if we can just back up for half a second and go into what exactly is a GUP.
Okay. The GUP stands for ground umbilical carrier plate. It's a steel plate that's on the side of the external tank that attaches to what we call the flight half, or the flight plate, where the vent line comes off the top of the hydrogen tank and allows us to vent off gaseous hydrogen, gaseous helium out through the GUP into the ground vent line, and so that excess hydrogen can be burnt off.
And we're actually now looking at video from the GUP right now, looking at the access arm that you were just talking about.
Mm-hmm.
So as you mentioned, and this is a closer look at the GUP area, and it has some additional dots around it that we don't normally see during a tanking process. What are those?
Yeah, that's correct. We went and put some ink dots on the inner tank foam that you see there, and as well as some on the actual carrier plate itself. Those are being used and tracked with a high-definition video camera to see if we can detect any motion in the carrier plate when the vent valve cycles and the slug of hydrogen gas passes through there. So we're looking to see if there's any kind of relative movement between those dots to see if we can learn a little bit more about the dynamics of the carrier plate during venting.
Unlike these particular alignment dots, as you were put on, I believe, by a permanent measure marker, as opposed to actually being hand put on like the other dots that we're using for the stringer sections.
Yeah, that's correct, and it's a little bit different process and obviously different equipment that we're using to look at it. So, but the principle is the same. You want to have something in the field of view that you can use to give you measurements, and that's exactly what those dots are providing for us.
Now, I believe if we go back, we have some video of this. Back, the actual repair process took place in early to mid-November, and the GUP's really just been kind of waiting until now for a tanking test.
We immediately went into that investigation I mentioned earlier, and we set up a plan for a forensic disassembly, taking a whole slew of measurements throughout the process. We ended up actually changing the carrier plate, as you can see in the video there. And once we got that carrier plate reset and everything, the new power bolt installed and everything set up the way we wanted it, we began a series of measurements called concentricity measurements to verify that the opening in the plate indeed was as aligned as possible with the opening in the actual external tank. Throughout that process, though, we actually came to learn we were not controlling a variable that was very important, and that was the concentricity of the actual QD itself.
And what we're just looking at here is actually the interior of the inner tank area, which shown at the very top of the tank there, and this is the quick disconnect you were talking about.
Yeah, that's correct. And you can see the quick disconnect, and as it's being mounted there to the carrier plate, that interface that at the very nose of that quick disconnect and where that actually lands on the seal is a measurement that we hadn't been controlling before. We felt that our previous process felt that the plate, as long as it was aligned, would give you good alignment of the QD. It turns out that each QD is a little bit different. Some have certain attributes that make them kind of pull the or put a load into the seal in the direction that we know that the vent line moves, and that's in the direction of badness. And so we went through painstaking efforts to select a QD and to install it a certain way so that we could actually move what we call the concentricity in the direction of goodness, away from the relative motion that the vent arm puts into the system. And when you're talking about a proper alignment, this is I mean really, really proper alignment. Yeah, this is space flight business. We're talking about tolerances in the thousandths of an inch and temperatures down to the minus 423 degree range of hydrogen. So the near perfect isn't perfect enough. So we learned quite a bit here, and we believe that we've got a process now. And thankfully, everything's been going extremely smooth today. No indications of a leak so far, and the tank is about 65-70% full now, and we're doing real well. We're real pleased with how everything is turning out today.
So again, without presupposing what's going to happen, but and you pretty much touched on it, though. Engineers believe you're pretty confident that you really do have the proper alignment, and this really is the fix. Because last year it seemed like we had gotten past the gup issue, and you guys had properly aligned it and shored up, shimmed it up, and then put those blocks underneath, and you've got a proper alignment of the plate itself, and that took care of the problem up till last month, actually.
Yeah, that's right. On STS 127, we had a similar leak to what had happened here, and we had gone through, and actually that's when we first learned about concentricity and the concentricity of the plate, the opening in the plate versus the opening in the external tank. But at that time, we never really considered the quick disconnect and its contribution to concentricity. So that's where we went off and focused on that process with this investigation, and that's a significant variable that we hadn't been controlling for before. And we think that, we've measured that there's some quick disconnects that automatically put us outside of our requirement window. So depending on which one was picked off the shelf and decided to be used for a particular stack, then we may have ended up putting in that condition from the very beginning. And so now, knowing what we know, we can avoid that.
So that would be the plan. Obviously, we've been joking about this with Mike Moses earlier, that if again, gup doesn't leak, that's good. It's a successful test of at least this portion. Now you're going to have to disconnect it, take it back into the vehicle assembly building, only to have to do it all over again.
Yeah, but what we need to demonstrate here is that it's a repeatable process, and we believe that everything that we've learned to date and incorporated into our revised procedures is going to make it so that we can certainly repeat the perfect or near perfect installation.
And what this video, just as right before we let you go, is that is actually the flare stack, where the end line of that vent pipe we were talking about. It's a little easier to see in the nighttime, but that's much like an oil refinery burning off the excess gas. It's the same thing. This is burning off the excess hydrogen, like you mentioned, and we get this question all the time, especially when we're launching a nighttime launch. Oh goodness, the shuttle is on fire. No, that fire's on purpose. That's it's doing its job. And okay, well, if again, like you said, we're getting near fill the tank so far. So good with the gup and the gup repair, and I wish you luck for the rest of the tanking test, and next time we make an actual launch attempt.
Thank you, Al. It's been a pleasure.
Again, Tony Bartolone, the lead external tank and solid rocket booster project engineer here at Kennedy Space Center, walking us through the ground umbilical carrier plate and the repair process that took place for that particular piece of hardware that actually caused Discovery's first launch attempt on November 5th to be scrubbed. And again, like you said, so far so good. Today we are not seeing any leak in that area, and haven't seen any other issues related to these stringers that we saw during the tanking process back on November 5th as well. So the countdown is in this tanking simulation is tanking countdown simulation is proceeding on schedule. And just to recap, the tanking process did start on time at 7 a.m. Eastern, and we went into liquid hydrogen fast fill at 7:49 a.m. and liquid oxygen fast fill at 7:50 a.m. And we are about roughly about an hour and 48 minutes into the tanking process. So at T-minus 4 hours, 11 minutes, and 40 seconds in this tanking test countdown, this is NASA Public Affairs.